Hello and welcome to part 2 of Intro to Functions. Now again, my advice on this one is to make sure that you do your study guide first and then use this as a way to check your answers, go back and make sure you know how to do everything. And just another reminder, make sure you're doing the after column in the study guide so you're writing yourself notes on how to solve each problem. It'll help, I promise. Alright, so it looks like we left off on numbers 9 and 10. And number 9 and 10, we're going to use the same graph. It says, between which 2 hours does the graph show the smallest rate of change? Well, I'm going to move this for a second. We can see that it's distance and time. That's a pretty common type of graph that we have, distance and time, because what that means is that when we're going up, what that means is our distance is increasing over time, or our rate of change is positive. Okay, then I see here it's flat, which says the distance stays at 100 from 4 to 6. So our distance isn't changing, which means we're just not moving. Here, this looks like a little steeper than it was here, so this would be a higher rate of change. And then back to a flatter rate of change. So if it says what is the smallest rate of change, will be right here. And the way you could write that would be indicated by either, you could say the smallest rate of change is between hours 4 and 6. Or, well, I guess in this case we'd have to say it like that, between 4 and 6 hours right here. If each part was labeled like we sometimes see, you could label it by parts, but it doesn't look like we can. Alright, next question says, what is the average rate of change from hours 2 to 6? Let me use a different color marker for that. So from 2 to 6, we're going here to here. Okay, so I'm going to trace up 6. It looks like our time gets to 100. And then from 2, if I trace up to the line, looks like it's 50. Okay. That information is valuable because we can find a rate of change. Some people can just do a rise over run starting from here, right on the line here, rising and running to see what our rate of change is. But what's also helpful is the picnic table equation. And if you forgot about the picnic table equation, it's because it looks like a picnic table. And you notice the x's are on the bottom, y's are on top. And what we will see in the future, we call this the slope equation. Y's have to go on top, x's on the bottom. And what we're doing in between is subtracting. That, of course, is our floating butter indicating subtraction. So where do these values come from? Well, they come from the graph. So if we're looking for the x values that are going to be on the bottom, they're on the x-axis. So 2 and 6 is what I'm going to plug in. 2 minus 6. Okay, now to find the y's, we have to find the y value that is associated with 2. So I trace up to the line, cross over, the value is 50. So I'm going to put a 50 here. And I'm going to do the same thing for 6. Trace up, value associated with it is 100. So now all we have to do is subtract and divide. So 50 minus 100 is negative 50. And 2 minus 6 is negative 4. Now, if you would have done them in reverse order, it would still get the same thing because a negative divided by negative is a positive. Either way, when you simplify this, we should get negative 50 divided by negative 4 is positive 12.5. Alright, so remember I told you one of the most important things that you can do in this chapter, or this unit, is trying to interpret what that means. So we answer the question. The average rate of change is 12.5. So the question is 12.5 what? Well, looking at our graph, we know that this is time and this is distance. So in other words, this rate of change means, it's distance in, does that say kilometers? It's really hard for me to see. It's small. Kilometers. So, alright, so that means what this is a rate of, it's 12.5 kilometers for every 1 hour. It's a speed. That means between the hours of 2 and 6, the average rate of change was 12.5 kilometers per hour. All right, next question. This is actually the last question. What are the domain and range represented in this graph? All right, we did a lot of work with this, and hopefully you're doing okay with this. When looking, let's start with the domain. Remember, domain is our x-axis. So we need to follow the x-axis to see what are the extreme values or the largest values on our graph. And I'm going to find, it looks like our largest value, our smallest value, sorry, is over here. Our largest value is over here. Okay, so our domain is between those two values. So I'm going to write that as an inequality. Our smallest value is 0. Our largest value is 8. It's a domain, so we're going to use the variable x, because somewhere in between, put our less than or equal to. And then, so that's essentially our domain there. But if we want to use our fancy function notation, we write it like this. We say the domain is d equals, that is it looks like a mess, but it's really a bracket. So x such that, that's what this means. Some people have been mistaking that for a 1. It just means x such that. Weird way to write it, but it's fancy math language. So this just means such that. Instead of all x such that, x is between 0 and 8. All right, so that's our domain. What about the range? I'm going to do that in a different color. Our range is on the y-axis here. So how high is our graph? How low does our graph go? If I'm going to find the highest point in the graph, I would point it here, like at the top of the mountain. And the lowest point is here. And we trace over to our y-axis, and we see that it looks like the lowest point is -3. And our highest point is 3. We're not going to use x this time, we're going to use y because it is the range. We put it in between, and we're going to have all y such that y is between -3 and 3. And that is our last question on the study guide, so we have that. I do want to make sure you got your credit for the study guide, so if you've been good and watched this all the way to the end like this, then here's what I want. On page 1, you can prove this when you show me your study guide. On page 1, I would like you to draw a pi symbol. On page 2, we're going to do sad face. We did a happy face last time. On page 3, even though that doesn't look like a sad face, it's weird, but you can draw a better sad face than that. Page 3, let's draw equal to sign. And on page 4 of our study guide, let's draw just a squiggly line. Okay, so label each page these symbols right here. These, you can put it on the page. That's how I'll know. I don't even have to ask that you did the study guide, and it'll be worth a little bit of extra credit for you. Okay, so, but before we go, I have a few shout outs to read. First shout out here says, shout out to Raiden. Where's the next comic? Coming soon enough. Soon enough. A little patience. Also have a shout out to Rebecca in 6th period from Caitlin. Also says, vote Sebastian for VP. I can't vote, so I'm just going to read what was put in the shout out bin. This is also a sticker that says Sebastian vote for vice president, so good luck, Sebastian. A lot of people supporting you. This one says Noah Westfall says hello with a smiley face. This is a shout out from Lydia to Vivi and Alyssa. It says calling Sudeikis and Bird. I'm sure you know what that is or who they are. Ashton Angel just says like and subscribe. Okay, and last but not least, we have 4 of the exact same shout out for some reason. It says Ruby and Rhiannon from period 4 are the best, and they are birthday twins. So happy birthday to our birthday twins. Alright, I will leave you with, don't forget that you are important, you are cared for, and you're listened to. I really hope this helps you do better on the test. Good luck to all.